Section 8.4 is the sine function. Our goal is to identify properties of the sine function and graph sine curves. On page 597, we have the sine function y equals sine of theta matches the measure theta of an angle in standard position with the y-coordinate of the point on the unit circle. This point is where the terminal side of an angle intersects the unit circle. You can graph the sine function in radians or degrees. In this book, you should use radians unless degrees are specified. For each and every point along the unit circle, the radian measure of the arc has a corresponding sine value. In the graphs below, the points for 1, 2, and 3 radians are marked on the unit circle. The vertical bars represent the sine values of the points on the circle translated onto the sine graph. So here we've got the unit circle with the points 1, 2, and 3 marked on them, and here we have the sine graph with the points 1, 2, and 3 marked as well. As the terminal side of an angle rotates about the origin beginning at 0, its sine value on the unit circle increases from 0 to 1, decreases from 1 to -1, and then increases back to 0. Example 1 says, what is a reasonable estimate for each value from the graph? Check your estimates with a calculator. We have sine of 2 and sine of pi. For y equals sine of 2, we have the sine function reaches its maximum value of 1 at pi over 2, which is about 1.57. The value of the function at 2 is slightly less than 1, or about 0.9. We can check this value by plugging sine of 2 into a calculator, making sure you are in radian mode. You should get 0.909. If you have your calculator set in degree mode, which it may be automatically set in, you will not get this value, so double check that you have hit the radian mode button. The same goes for Desmos. Make sure you are using Desmos in radian mode and not degree mode. For part B, we have sine of pi, which we have right here on the x-axis, meaning the value of sine of pi is 0. If you check this on a calculator using radian mode, when you plug in sine of pi, you do indeed get 0. The work for this problem is written out on the next 2 slides. And now I would like you to try number 1. Use the graph at the right to find the value of y equals sine of theta for each value of theta. Here we have 5 radians.